Okay, well, this matches the form of the integral of x over the square root of x squared plus or minus a squared. Right? Okay, and of course this integral is given in a table. Now, in the first place, this integral is really easy to do. Use a u substitution, let u equal x squared minus 9. Okay? And you're going to have a 1/2 du in your x dx. So you're going to have 1 over 2 square root of u du. Okay? So it's very easy to do this integral, but we're using it as an illustration because some integrals that are much harder to do or that you don't even have the techniques to do can still be performed just by using a table of integrals. And that's what we're talking about now. Your book has a good table of integrals. And if you want a more extensive table, just look up table of integrals on the web. Okay? You get extensive tables. You probably will never need anything more than the simple table you have in your book, which is actually a fairly extensive table. Okay? Covers most anything you're likely to run into, and a lot of things that you aren't. Okay? And what's the parameter here? Parameter is a. Okay? Here, your variable is x. The parameter is a. So what would the value of a be? Yeah. Because then and I guess the plus minus is kind of a parameter, not technically, but you know, you got to use the right symbol, right? And this integral is nothing but if I let, okay, get 2u du, and then my antiderivative would be 2 times, so the integral is just the square root of x squared plus or minus a squared, right? And I believe that's what the table says. Because the table can't possibly disagree with what I get. Okay? The table might be wrong, you know, if I get something that's wrong, but yeah, that never happens. Okay, and you're allowed to laugh. Okay, so if you choose the plus or minus, then the integral of x over the square root of x squared minus 9 dx, without having to go through all the detail, is going to be the square root of x squared minus 9. Because if we let a equal 3 and choose the minus, that's what we get, right? Again, that integral you wouldn't even bother with the table because it's so straightforward. But if you happen to just really need to get the integral, okay? Incidentally, I probably should have put a plus c on each of these because they're all indefinite integrals, right? If you happen to be in a situation where you need the integral fast and you just get yourself confused, and you know, not likely to happen on this integral, but on a slightly more complicated integral, you know, you might go to a table. Okay? Okay, well, look at the second question.